We're going to go ahead and look at notes 10.2, which is simplify radicals. And while we're looking at this, first of all, I want to remind you to get everything written down. Pause, rewind if you need to. Okay, so first of all, what is a radical expression? Well, it's an expression that contains the radical symbol. Most likely you can think of it as the square root symbol. How do we know when a radical is simplified? Because that's what we're looking at here, is we're going to take these expressions and make sure they're simplified. Well, ones that are simplified, and some examples would be 3 root 5. That is simplified. 5 is a prime number. We could also have letters inside our radical. So if we had 9 root x, the square root of x times 9, that is also simplified. We can also have fractions. So let's say the square root of 2 divided by 4. That is also simplified. What we have to be careful about is the radicand, which is what's on the inside. We need to make sure there's no perfect squares except one inside of there. So 5 is not a perfect square, and 2 is not a perfect square, and the letter x is not a perfect square, which is why that's simplified. We can't have fractions where the radicand is actually part of that fraction appearing in the denominator. We cannot have the radicand appear in the bottom of the fraction. So some examples would be if we had the radical in the denominator, so 5 square root 7. 5 divided by, 5 divided by the square root of 7. This one is probably hard for you to see, but 3 times the square root of 12. There's actually a perfect square that makes up the number 12 there, and so that is actually not simplified. And then if we have the entire fraction in the radical symbol, so we have the square root of, or we have x divided by 2 all in the square root symbol. Those are not simplified radical expressions. So we're going to talk about how do we do that. So down below you see that we've got some perfect squares here. Okay, we know the square root of 1 is 1, and we know the square root of 4 is 2. And the square root of 9 is 3, and I don't think I need to keep going. I think you can finish the list. These are all our perfect squares up to 100. The square root of 25 is 5. So fill those all in, because we are definitely going to want to make sure that we are looking at perfect squares. So with that being said, let's go ahead and look at our next slide and talk about how do we go through these and solve them. Simplify them. So here on slide 2, we have the square root of 160, and we want to simplify that. Okay, I'm going to highly suggest that the first thing you do is you write out what we call a prime factorization tree. Okay, so how do I do that? You're finding out what numbers multiply together to get 160, and we want those to be our prime numbers. So I'm going to start with 160. Tell me 2 numbers that when you multiply those 2 numbers together, you get 160. Well, 10 and 16. You did not have to use 10 and 16. You could have used 20 and 8. Okay, so you don't have to use the 2 I did. You could have used 2 and 80, cut 160 in half. I chose 10 and 60. We continue because 10 and 16 are not prime numbers. So what makes up 10? Well, 2 and 5. 2 and 5 are prime numbers, meaning they can only be divisible by 1 and itself. So I'm going to circle that. And if I look at this 16, I know 4 times 4 gives me 16. And 2 times 2 gives me 4. And 2 times 2 gives me 4. And so if you were to type in your calculator, everything that we circled here are prime numbers. 2 times 2 times 2 times 2 times 2, 5 times the number 5, you would get 160. So everything we circled there, we're breaking it down to a prime factorization. Now that we have done that, that's what we're going to write inside of our radical symbol. So I'm going to write it up here, 2 times 2. And what we're going to do is we're going to look for perfect squares. Well, we know that 2 times 2 is 4, and that's a perfect square. You told me on the last page that the square root of 4 is 2. So I always draw a circle around the two of them, and I draw an arrow out of the radical symbol because the square root of 4 is 2. It's going to be a whole number in front. And I have another group because another 2 times 2 gives me 4. And the square root of 4 is also 2. And now we have 2 and 5, and I can't take the square root of 2, can't take the square root of 5. They're going to stay inside the radical symbol. So if when we call this simplified, we have pulled all of our perfect squares out. You're left with a 2 and a 2 in the front of our radical symbol. And we have a 2 and a 5 on the inside of our radical symbol. And so 2 times 2 is 4. And you have 10 left on the inside. And that is your simplified radical. That's it. So we are pulling out our perfect squares. Some of you might see the perfect squares and not have to actually write down all of your prime factorization. Let's look at another example. Sometimes you are going to see that we have letters as we have to the on example 2 here. So if we look at example 2, and we can see that it says 54n to the 7th. So let's go ahead and write out 54, and let's write out our prime factorization. We know it's going to be 9 and 6, 3 and 3, 3 and 2. Those are all our prime numbers. I got 9 times 6 is 54, making my prime factorization tree. And remember, if you take everything that you circled, 3 times 3 times 3 times 2 will get you 54. Let's go ahead and write this out. So I always put them in order by just value. 2 times 3 times 3 times 3. And we have 7 n's. And so we're looking for perfect squares. Well, 3 times 3 is 9. So we know that that is a perfect square because the square root of 9 is 3. So that's going to be in the front of my radical sign. We know that an n times n is going to be n squared. And if you take the square root of n squared, you get just an n. And we have another n times n, which is n squared, and if you square root that, you get just n. And we have another group of n times n, and if you square root that, you get n. So everything that can be pulled out to the front that we can take the square root of that ends up being what we call perfect squares would be a 3n to the 3rd power because there are 3 of them. And what we have left in our radical symbol is a 2, a 3, and an n. And when you multiply your 2 and 3 back together, you get 6n. And so that is how you would simplify. You're done. That's where you would stop. You have no more perfect squares inside your radical symbol. Let's look at one last example. So this last example here is looking at what do we do if we multiply 2? And I wrote the formula up there, the square root of a times the square root of b. Well, they can just, when you multiply, just put it all underneath one radical. So that's what we're going to start with. We're going to start with just writing the 2 times 3 out front. And underneath one big radical symbol, let's just write 7 times t times 14 times t squared. It can all go under one radical. And we can start to simplify. We know that 2 times 3 is 6. So that's going to be in front of my radical symbol. And let's go ahead and we're going to leave the 7. But what about 14? 14, if we did our prime factorization, is 2 and 7. So I'm going to break that 14 up to a 7 and a 2. And I'm going to put all my t's. And I have 3 of them because t squared is t times t. And I have one other t, so t times t times t. Again, looking for our perfect squares. 7 times 7 is a perfect square. The square root of 49 is 7. So out front, I'm going to have a 6 times 7. And t times t is t squared. And that is a perfect square. And so we have a t out front. What we have left in our radical symbol is a 2 and a t. And so if we simplify out front, 6 times 7 is 42t. Square root 2t. And that's it. That is simplified. It is simplified because we have no fractions. It is simplified because you have no perfect squares underneath the radical symbol. I have practice for you for tomorrow. I hope you got all of this written down. Have a great day.